All right, so in this video, we're going to look at the 2.1 quadratic function word problems, and sometimes in calculus, it's called optimization. Okay, so there's actually, as I mentioned, you could use calculus to solve this, but again, we're in math analysis, so I'm going to use basically algebra to solve these optimization word problems. So let's take a look at problem number one. Again, follow along with your notes that I've attached. So if you're wondering where are these problems coming from, it's the 5 problems that I attached on Google Classroom. Okay, so first problem reads, find 2 positive numbers whose product is a max if the sum of the first number and 3 times the second number is 42. Okay, so let's read that again. I want to maximize the product, right? So over here, I'm going to say P parentheses XY, right? I want to maximize this. And if you read the second sentence again, right? Or actually, it's one sentence, but the second part, find 2 numbers whose product is a max if the sum of the first number, so we'll call X is the first number, and 3 times the second, right? 3 times the second is 42. Okay? So remember when you guys did all those, write this as a function of something? So this is where it's kind of handy. You want to put everything in terms of one variable. And it doesn't matter which variable you want to put it in terms of. Okay, so for this one, I'm just going to put it in terms of X. So if I want to put it in terms of X, right, this second equation right here, I'm going to need to get Y by itself. Okay, so 3Y is equal to 42 minus X, right, and divide both sides by 3. Okay, so you could write 14 minus 1 over 3x, and you can substitute into this first equation. All right, so now you take a look at it, right? Everything is a function of x. And the question is, I want to maximize, right? Find two positive numbers whose product is a max, right? So I want to maximize this. Now, when you're talking about max, right, and we're not doing calculus right here, the maximum or minimum of this is called the quadratic function, right? Because if you FOIL it, you're going to get x squared. And if you think about it, right, you could write it like this, negative 1/3 x squared plus 14x. The maximum, it just refers to the y value, the vertex, right? And so what you need to do is find the vertex. So I want you to take a look at this equation. There's a couple of ways of getting the vertex, right? This guy right here is in standard form, right? And this guy right here is in intercept form. So whichever form that you're more comfortable with in finding the vertex, you're welcome to do that. Most of you are probably comfortable if x is equal to negative b over 2a. Some of you want to recognize that this is an intercept form, so you could just do p plus q divided by 2. It doesn't really matter. So for this one, since I already FOILed it, I'm just going to use x is equal to negative b over 2a. Okay, so over here I'm going to get 14. I'm going to erase that here. 2 is going to go into 14 7 times, right? And you have a negative or negative, which is a positive. 7 divided by 1/3, right, is just 21. Okay, so 21 is going to be one of the numbers. How do you get the other number? You plug it back in. Okay, so y is equal to 14 minus 1/3 of 21. 1/3 of 21, of course, is just 7. 14 minus 7 is just 7. Okay, so these are 2 positive numbers whose product will give you a maximum, and it meets this parameter right here, right? The sum of the first plus 3 times the second will give you 42. All right, so you might be wondering, like, how do I know if this is a max or min, right? This parabola is going down, and so if it's going down, you know you're going to have a max. Okay. All right, so let's take a look at the second problem. It says a ball's flight can be modeled by the equation y is equal to this. Okay, so this one I'm going to copy it down. Y is equal to negative 0.002 x squared plus 0.2x plus 5. where x is the horizontal distance in feet, y is the height in feet, what is the ball's initial height? So for part A, right, initial height just refers when x is 0. Okay, so initially, right, when I plug in 0, it's basically just the y-intercept, right? Y is equal to 0 plus 5. The initial height is 5 feet. Okay, typically, right, they write y as a function of time, but this time they say y is the height, x is the horizontal distance. Okay, so that's the initial height. What is the ball's maximum height, right? So again, that key word right there, maximum height, question mark. The key word is max, right? Or if they say min. So whenever they say max or min, right, you want to use the vertex formula of x is equal to negative b over 2a. So let's do that. X is equal to negative 0.2 over 2 times negative 0.002. And if you plug this in your calculator, it looks like you're going to get 0.2 divided by 2 times 0.002. It looks like you're going to get 50. Okay, so 50, right? 50 is, the units is feet. This is the horizontal distance, right? So be careful when it's asking for the maximum height that you don't assume that the answer is, the x value, right? Whenever they're talking about max or min, it's typically the y value of the vertex. Okay, so make sure you plug in y is equal to negative 0.002 times 50 squared plus 0.2 times 50 plus 5. This will give you the maximum height. So evaluate that as I enter this on my calculator. Plus 0.2 times 50 and then plus 5. Okay, so you're going to get 10 feet. 10 feet. This is the maximum height. All right, now it asks, what's the total distance the ball traveled horizontally before it hits the ground? What is the total distance the ball traveled horizontally before it hits the ground? Okay, so when the ball hits the ground, right? So perhaps it might be useful to, draw a little picture, okay? So we already know that the vertex of this graph is 50, 10, right? So 50, 10, I don't know, somewhere over here, okay? Not drawing the scale. And the initial height we said was 5 feet. It's going to look something like this, right? Okay, so the question is, how far did it travel horizontally, right? That's really what the question is for this particular problem on part C. Okay, so when the ball hits the ground, right, you'll realize that the height is just 0 feet, right? And so my goal right here to solve for the horizontal distance is I'm going to set y equal to 0 and then solve for x, okay? And that will give me the horizontal distance. Okay, so set y equal to 0 and solve for x. All right, so if you take a look at this problem right here, right? One way to solve for x, of course, is to plot it on Desmos, or you could use the quadratic formula. Okay, so I would just use the quadratic formula, and you can verify this on Desmos. Okay, so x is equal to negative b, negative 0.2, plus or minus the square root of 0.2 squared minus 4 times a times c all over 2 times a. Okay, all over this. Okay, so you can, simplify this using your calculator. And let's plug in some numbers over here. 0.2 squared minus 4 times negative 0.002 times 5. Looks like I'm going to get 0.08 inside my radical. .004. Okay, so these negatives are going to give you a positive number. So we can cancel that out. 0.2 plus or minus, oops, let me rewrite that. 0.2 plus or minus the square root of 0.08. Looks like you're going to get 0.28 to divide by 0.004. Okay, so if we add 0.2 plus 0.282 divided by 0.004, what are we going to get? It looks like we're going to get 120.5 for one of them. And then if you do 0.2 minus 0.282 and you divide by 0.004, you're going to get negative 20.5, right? Now, clearly, if you look at your graph, right, the reason why you have negative 20.5 is because it hits the x-axis right here, right? This will be the other x-intercept, negative 20.5. And this guy right here is where the horizontal distance is, okay? 120.5 is going to be your final answer on this problem. Let me just double check here. Okay, so, you know, if you're off by a little bit, that's fine. In your, in the answers on the bottom right here, I wrote 120.7. Okay, so there's a little rounding error. If you're able to enter everything and just save it, or sorry, do it in one line, you'll get something close to 120.5 or 120.7. Okay, so make sure you write the units.